Hello everyone, hope you're doing well. In this video, I'm going to talk and walk you through a completely new topic, right? Which is going to be modern cloud native architecture, right? So I'll make you understand what is it actually, how it really works, and what are the things those are part of this one, right? Now you might be wondering, we know cloud, but what really is the cloud native architecture, right? How it is going to help me and organizations to build a solution which is going to be performance efficient, cost effective, and also going to meet security compliance and regulations, right? Along with that, it is going to also help to mitigate so many different activities and different workloads or different manual actions that we would end up or we generally end up doing many things, right? So now when it comes to cloud or when we say any cloud platform, definitely there are many things to manage and do and work upon, right? It's not something earlier we had on-premises environment, and even today also there are many companies who are relying on on-premises infrastructure, and they do have systems, applications, and everything together, which they have invested a lot about on them, and they are also trying to optimize on premises, and they are also trying to understand and make real use cases of the cloud, right? It is not something just we are saying that we wanted to move from on premises to cloud, then let's go ahead and do it now, right? Instead of doing that, we should also think about the different aspects of it, how it is going to solve the business issue, business case, business requirements, and upon that definitely we should be doing either migration or anything that we wanted to either build a solution from scratch within cloud itself, or we should be relying onto the on-premises or doing the hybrid kind of setup, right? So let's jump onto the topic and I'll walk you through what is it and how it actually works, right? And I'll cover a few different topics in that as well. All right. So this is the modern cloud native architecture, right? Which is going to be, or which is happening now as well, but I put in future of application design and operations together so that it is also happening. As you can see, it is a part of containers, orchestration, and observability, right? It's happening together these days also, and many companies do have their different systems and platforms and everything hosted in this modern architecture, right? So let's jump on and I'll walk you through. So it's a simple question. What is cloud native architecture? Right. So it's an approach basically to build and run applications that's going to leverage pure cloud computing resources and its advantages with scalability, automation, and resilience. And apart from that, there are other as well, including performance, security, compliance, and everything together. Right. Now, there are certain attributes, or you can say the architecture based, including microservices, containerization, dynamic orchestrated, observable, and automated with automations, and designed for continuous delivery. So, which is also going to adopt DevOps practices, including DevOps, DevSecOps, and DevSecRegOps as well, right? So, I have talked about DevSecOps or DevSecRegOps in another video. You can watch that out too. But you can see the list of attributes over here. Those are falling behind and under the DevOps practices, right? And those are a part of CI/CD. So that's going to be definitely helping us to do the continuous integration, continuous delivery, and continuous deployment across the platform or the organization that we are going to either build solution from scratch or going to modernize the existing ones and put that together to build that solution, right? So in simple terms, you can see this is going to be the cloud native architecture, which is going to support and rely on all of these attributes over here. There are three pillars, and those pillars would be starting from containers, orchestrations, and observability, right? So containers is going to be packaging the applications and building those and push together. That's going to be continuous integration, right? Or continuous deployment, you can see, right? And then orchestration, including automate deployments and scaling that current states, right? Because when it comes to deploying applications and systems in the larger environment, it is not easy to do that manually and a kind of uh, a steady approach, right? It should be automated way. It should be from one go to the everything and should be expanded to the broader level, right? So that way it is going to be with the orchestration and observability to monitor, analyze, and optimize systems effectively from cost management side, from performance, from system optimization way, including all the workloads that we are building, be it a SaaS infrastructure or be it a infrastructure as or it is a SaaS based as well, right? So majorly it is going to be PaaS and infrastructure as services, but definitely is going to help in all those scenarios where it is a serverless architecture, where it is a event driven architecture, or whether it is a cloud native one, which falls behind the Dockers, Kubernetes, and all those stuffs, right? So the tools basically would be Docker, Kubernetes, Prometheus, and Grafana as well, right? So Prometheus and Grafana, those are monitoring observability tools, but the Kubernetes and Docker, those are the real containers and orchestration mechanisms or tools, I would say here, right? So the next one is container, right? Which is a cloud foundation for native applications, right? So containers are something like those are the lightweight and easy to deploy and build applications, and it is a portable environment basically, right? And there are dependencies as well on each other. So there are some of the benefits and a simple analogy that you can understand with the containers, a kind of a specific box wherever you can carry something in that particular box, or maybe let's say a office bag or school bag, right? You can put something there and you can carry it. So similarly, the container is going to be the same, where you would be putting and hosting your applications and services, and from there those services would be delivered and working as expected, right? So we have to talk about the benefits, including portability, efficiency, speed, and consistency, right? So this is going to be that way where we would be enforcing, or the deployments would be deployed, and we would be, or we would have a benefits of that, including portability, which is easy to move or create or maybe simply discard if in case needed, right? On the same time, we have a efficiency of the services and speed of that, along with the consistency, whatever we are going to deploy, the same is going to be deployed there too, right? So it's going to be consistent in nature. How containers actually works, right? So the containers is something which is a kind of isolated environment or isolated namespaces, right? And it also uses the OS or shared OS kernel on the actual, be it a virtualized environment or be it a on-premises environment, where it is going to start from the shared OS level, right? Because it's going to create a separate name spaces, and then it is going to be there residing in that particular area. So it is not going to impact to other isolated areas if in case there is something wrong in the node A or node B or whatever node, only that respective node is going to be impacted, right? So that way it is going to be isolated and easy and separate for. And it is going to start and stops in seconds. So it does not take a lot of time. And if you have to talk how container really actually works and build its underlying infrastructure, there is a lot to talk about, because container itself, it has a lot many things that happens behind the scene and behind the OS kernel, right? So those are the things which would be there as well. So to simple and to understand it better way, the example could be, let's say, front end, which is going to be a React, and back end is going to be class plus database with Postgre, right? Which all runs in a separate containers, right? So whatever the workload that we are going to host, that's going to be a separate out, and everything is going to be running from different nodes, right? Even if we put a database in a separate node and front end and back end is put in a separate node, then definitely there is no, or there's nothing which is going to be impacting each other. Even the front end goes down, then it is, or it does not have impact on backend or the database, right? And if both, or if everything is installed and deployed in the same server, then if something goes wrong, then other are also impacted some or the other way, right? So that way it is going to be impacting as well. Orchestration, managing containers at scale, right? So how you are going to manage and how we can make sure that is working as expected, right? Why do we need it actually? Containers multiply fast, right? You would need an automation for deployment and scaling and recovery and everything together, right? To do that, we have some of the different ways for Kubernetes to automate scheduling, scaling, load balancing, health checks, and configuration management, right? So these are the areas which would also be implemented, and those would also be helpful for managing all those containers in scale, right? Because it is not something, and why do we say that, or why do we really need it, right? Because if we have an multi-service architecture, right, or microservice architecture, I would say, that means we would be end up hosting different services across different nodes, and definitely we have to manage everything from central point of view, right? So definitely that's something we have to go ahead and take that way and approach as well to go ahead and manage it, right? So yep, that is how it is going to be. And Kubernetes in action, to understand it better way with example. So this is one of the example I put, which is an e-commerce application which is deployed across 3 front-end pods, 2 backends, and 1 database, right? Now, Kubernetes autoscales, which is going to be expanding its services and operations. And if restarts failed pods, then what is going to, it is going to update and going to push that again and updates without downtime. So it is not going to impact any other services, and only the respective node is going to be disabled, or that respective node is not available due to either connectivity or a database failure or any other connections that is going to, that is brought down to, right? So the overall respective service is down, but the whole system is not down or crashed at all, right? So this way it is going to be very helpful and is going to be applicable as well, right? So that's how it is going to be. Next is observability, right? Where you can see and hear the noise of issues, right? Which is basically ability to understand internal system states from external outputs. So this means that it's beyond the monitoring, right? Monitoring tells what is happening, how it is actually working inside the system and services, and observability tells us why, right? Why this is happening, why that was happened, or why, what was the reason that was crashed, right? So basically to understand everything, including native tools as well as third party tools like Grafana and Prometheus, right? Those are the tools, those would also help us to decode our what and why, so that we get to see and we can take the appropriate actions, right? So those would be helping us there too. 3 pillars of observability, you can see, start from metrics, logs, and traces. So under metrics, we have numeric data, including CPUs and latency and everything together. On the log side, we have system events. What are the events? What those events talk about, and why those events were occurred, right? And then traces, which is going to show us flow across microservices. So collect the different details and show us in front of us through the respective tools, and then from there we can identify what's happening actually, and then resolve those. So by using the Prometheus or Grafana or OpenTelemetry or with ELK stack, right? So those are the different tool sets that we can leverage for. And bringing it all together, so starting from containers, orchestrations, and then observability, right? So full flow of the application components in containers, right? And then Kubernetes manages the whole life cycle, and observability tracks health of the whole system, right? To make sure those are up and running, those are working as expected, and we can take the actions. So here it gives us clarity. So instead of doing uh, reactive, we should be doing it proactive and taking the further steps to be able to identify the system issues, causes, problems, and then we should be working on them proactively, right? So that's how it is going to be. And the example here to understand it, Docker, Kubernetes, and the observability tools like Prometheus plus Grafana, right? So in combination of all this together, it's going to become and is going to be a cloud native complete architecture. Why cloud native matters, right? This is going to be something which is also uh, very important. And from all of these pointers, you can see on the screen, from faster to the time market, right? Then high resilience, scalable systems, easier automation, and cost efficiency, right? So not only this, but there are many other factors as well to stay or be in the cloud with the cloud native services and approaches and the right set of implementations, right? And what are those organizations? I've mentioned few of them here, which are relying on this way or these systems, definitely some or the other way, right? And those would also be using different approaches or different systems, right? So to sum up, cloud native is going to be the real one, and many companies and businesses are still and they are using it, right? So maybe there is no going to or there's not going to be an on this one, and definitely the approaches might be different for each of those organizations that they are utilizing and that they are using, right? So it is basis on their needs and requirements and how they wanted to put that systems together from cost efficiency or scalability or higher performance and resiliency, and how they wanted to how those systems should be available for the market as well, right? So yeah, that's how it is going to be. And in summary, from cloud native, which is going to help us to build faster, deploy smarter way, and operate it intelligently so that we are not stuck and left behind, right? And we are ready for the market as well. So containerizes or containers, which is going to simplify our workloads using and deployment of Kubernetes and automates and observability, right? So that's going to give us a complete path there, and together everything going to become a modern cloud ecosystem, right? So whatever we are going to build, host, deploy, including and following the DevOps practices, CI/CD and continuous delivery and continuous deployment, continuous integration, that's going to be, of course, helping in that situations as well, right? So yep, that is what I wanted to talk and walk you through about this one. So what is going to be the uh, modern cloud native architecture and how it is going to be helpful, right? Definitely, there are different ways and approaches to take, but this is something from the ground level or from the basic to the next step, right? So, yep, that's all for this video. Hope you learned something new. Hope you like something about it, and let me know if you have any questions, any doubts, and anything that you wanted to ask, and I'd be happy to answer them. And don't forget to like it, share it, and subscribe to the channel as well so that you get to see every new video whenever it is uploaded. So that's it. Thanks for watching, and bye for now.